All right, so we are in Algebra 2. This is my lesson after class because people asked me to record it since our projector was being worked on. Today's date is Friday, December 6, 2019. Yeah, so we are rewriting exponential expressions today. So we're using properties of exponents to rewrite exponential expressions. But in order to even use those properties of exponents, I need to make sure that I have the same base. And that's where a lot of our problems are encountered, like base of 3, the base of something. Well, I guess that one is not a case, but definitely over here I have a base of 1/16, a base of 1/2, base of 1/2. I have to get similar bases. Let's go ahead and start with example 1. So I basically need to say this 2 to the power of x minus 7 plus 2 to the power of x needs to be a times 2 to the power of x. And I don't know what a is. I'm trying to find a. What is the value of a? So how do I set this problem up? What happened there? So I'm basically saying these two equal one another. So I start by saying 2 to the power of x minus 7 plus 2 to the power of x. That is equal to a to the power, or a times 2 to the power of x. And again, somehow I'm going to get I don't know what it is, I'm going to call it a, something times 2 to the power of x. Since I am multiplying by 2 to the power of x, I know that this something, I don't know what it is yet, is going to be multiplied by 2 to the power of x. Which means, if I come back here, I'm really saying 2 to the power of x is going to be factored out of both of these expressions. And when I say factor out of, that's the same thing as dividing by. I'm dividing this term 2x, 2 to the power of x minus 7, I'm dividing that by 2 to the power of x, and I'm dividing 2 to the power of x divided by 2 to the power of x. And this is one of the rules. Whenever I divide with similar bases, I'm subtracting their powers, which means what's left over in here is it was originally, I'll rewrite it, 2 to the power of x minus 7, but I'm dividing by 2 to the power of x, which is the equivalent of saying I'm subtracting by x. I'm subtracting x in the power. So plus 2 to the power of x was the original thing that I had, but I'm subtracting a power of x, so minus x. This is the long way of doing it, by the way, I should mention. There is a shortcut, well, not really a shortcut, just knowing that I'm kind of removing an x from both of these unless it's the same exact function. So I'm simplifying this. When I do x minus x, these two cancel out, so x and x are gone. X minus x, that turns into just 0. So now I have the expression on the left-hand side, 2 to the power of x times 2 to the power of negative 7 plus, this is 2 to the power of 0, and I'll come over here on the left-hand side. 2 to the power of 0, anything to the power of 0 is 1. So this, I say anything, it's a tiny little lie. It's 1. And I should mention, of course, on the right-hand side, we still have this a times 2 to the power of x. That hasn't gone anywhere. I just forgot to copy it down. So it's still a times 2 to the power of x. All right. Well, now I have a quantity. If I were to switch these two around, I'd have a, this is the a, and then this is the 2 to the power of x. This is a, this is 2 to the power of x, which means essentially what I'm doing on both sides, and I'm dividing by 2 to the power of x, or just eliminating them on both sides. Which means there is my a. A is equal to 2 to the power of negative 7 plus 1. But the problem is you need to simplify this. I don't like negative powers to enter in my answer. So I now need to say, okay, if I have a negative power, and it's this rule over here that I can review, if I have x to the power of negative, 3, that turns into 1 over x to the power of positive 3. So that means if I have 2 to the negative 7, that turns into 1 over 2 to the positive 7. And this is still plus 1. That is all equal to a. And I ran out of room, so I'm going to come back over here. And I'm going to say, okay, well, what is 2 to the power of 7? That's 2 times 2 times 2, all the way 7 times. That is 128. So now I have 1 over 128 plus, and I want to write 1 here, but I know that I'm going to have like denominators. So I'm going to say, oh, 1 is the same thing as 128 divided by 128. And that's still equal to a on the right-hand side. And now I can add them because I have like denominators, and I can say, okay, my final answer is 129 over 128. That is my answer. That is a. That's the thing that I was trying to find. Let's move on to example number 2. Same type of question. I'm looking for a. What is a when we say this 3 to the power of x is equal to a to the power of 7x? So let's go ahead and set that up. We're saying 3 to the power of x is equal to a to the power of 7x. So I basically need to somehow find a, and I know that I'm always going to have 7x. So I need to have a 7x up here. And I can just put that, but I need to follow the rules of exponential, or rules of exponents. So I'm going to go ahead and say, okay, I still have, on the right-hand side, I still have a to the power of 7x. But on the left-hand side, I need a 7x in the power. And I still have a 3 for the base. So what could I do in here? And I guess I do need more room, so let me move this over a little bit. 7x. I need to do 3 to the power of something to the power of 7x, such that my left-hand side is still equal to one another. All of this should still be equal, and it's not equal right now because now I have 3 to the power of 7x. Up here I have 3 to the power of x. So what can I multiply 7x by to get to x? And the answer is, well, 1/7. So 3 to the power of 1/7 time, or to the power of 7x, is the same thing as 3 to the power of x. I haven't changed the left-hand side. It's still the same side. And check this out. So now I have the same exponent here and here, which means since this is an equal sign, the bases must also be the same. I'll say that one more time. If I have the same exponent on the left and the right, then I must have the same base on the left and the right, which means a is equal to 3 to the power of 1/7. And you can enter it like that. I think it's probably going to be a multiple choice question at this point. Or the alternate form is the 7th root of 3. Both of those are the correct answers. I think that this is the one that you'll probably see on the homework. I should box that one. Let's do example number 3. So, what is the value of f of x? What is this thing right here when we rewrite these two terms being multiplied to each other equal to this right-hand side? So I'm going to kind of replace f of x. I'm going to say that's our question. What is that thing? I'm going to call that a question mark. I think it's a little bit easier to understand that way. So I'm going to come down and rewrite this. This is, let's see how small. If I zoom in, I can write a little bit smaller. So this is 1/16 to the power of x times 1/2 to the power of 7x plus 2. That now needs to be equal to 1/2 to the power of, and I'm going to call this question mark now. What is this question mark? That's what we're really trying to solve for. So I need to use rules of exponents, which states if I have same bases and I multiply, then I add the powers. Well, I don't have the same base. I have 1/16 and 1/2. Those aren't the same, but I can make them the same using a few little tricks. The first trick is knowing what is 16 in terms of 2. Well, and you should know this, that 16 is equal to 2 to the power of 4. So I can come and rewrite this equation. I can say that's 1 all over 2 to the power of 4, and that was 1/16. So I've copied down 1/16. It's still to the power of x. And that's the only change I'm going to make. I'm going to rewrite everything else. So this is times 1/2 to the power of 7x plus 2 is still equal to 1/2 to the question mark. Okay. So I'm almost there. I almost have the same base. What I'm going to do now is this little rule. Let me come over here to the side. So this little rule is the one that says if I have, I don't know, a over b, and this is all to the power of, I don't know, something. I'm going to call it x, I guess. This is equal to ax over bx. I'm distributing this x into both the top, the numerator and denominator of the fraction. I'm going to do the reverse of that. I'm basically stating right now, I start with this, and I'm going to go in this direction. So essentially, my rule is stating this. If I have 1 over 2 to the power of 4, that's the same thing as 1 over 4, 1 to the power of 4 divided by 2 to the power of 4. I think we can all agree that this fraction and this fraction are the same, because 1 to any power is still 1. And then I'm going to come back and I'm going to undo that rule, and I'm going to say, oh, that's 1 over 2 to the power of 4. That's the rule that I'm using here. So I'm going to rewrite this. This is now 1 over 2, all of this to the power of 4, all of this to the power of x. Because this main parentheses right here is still this parenthesis right here. That means everything inside the parentheses is the same. 1 over 2 to the power of 4 is still 1 over 2 to the power of 4. I said it the same way, but it is a little bit different in the mathematics. And again, rewrite all of this stuff again. So this is still times 1/2 to the power of 7x plus 2 is equal to 1/2 to the power of question mark. Okay, I'm really, really close now. When I take a power to a power right here, that means I'm multiplying the power. And that means I have 1/2, all of this to the power of 4x. And that's going to be times 1/2 the power of 7x plus 2. And that's going to be equal to 1/2 still to the power of question mark. Okay, I finally achieved my goal. My goal was to get similar bases, the same base, same base, same base. I've done that. Now I can finally use my rule of exponents that states if I am multiplying the same base, I'm really adding the powers. I'm adding this 4x and 7x plus 2. So my next line down here is going to say, okay, this is really 1/2, all of this to the power of, and I'm going to add these. 4x plus this other one, 7x plus 2, and that's all equal to 1/2 to the power of question mark. Okay, this is the same rule that I was using for every single one of these. If I have the same base and the same base, then the same exponents must also be equal, or I must have the same exponents. If I have the same base, I must have the same exponents. And this is another one. I have the same 1/2, 1/2, which means in order for this equal sign to still be true, these exponents here and here must be the same, which means that question mark is equal to 7x plus 4x plus 2. This, or I guess I should say it correctly, 4x plus 7x plus 2. And I'm going to go ahead and simplify that. So our question mark, which is really the thing, it's called f of x. It's really f of x in this case, is equal to 4 plus 7 is 11. So 11x plus 2. And there's our final answer. Moving on to number 4. What is the value of f of x when we rewrite this thing as this? So whenever I see the word as, I'm always thinking, okay, that's an equal to sign in my head. So let's go ahead and rewrite this now. Let's zoom in so we have enough room. Actually, I do need to zoom out. So this is now 49 on the top in the numerator, divided to the power of x, all of this divided by, okay, I made this mistake in class, and go ahead and do it now. Everyone gets the extra credit point. This should not be an x. The bottom here should really be 7 to the power of 6x plus 5. That's how this thing should really be rewritten. There should not be an x there. So that's my mistake. So this should now be 49 to the power of x divided by 7 to the power of 6x plus 5. And that is going to be equal to 7 to the power of, and this time I'm not going to change this to a question mark. You can if it helps you. I just use that to kind of help people see, okay, that's the thing we're trying to solve for. I'm going to leave this as f of x. That's the thing, this is the thing that I'm trying to solve for. Which means I need to get the same base. If I get the same base here and here, then these exponents, whatever they are, must also be equal to, and therefore the exponent will be the answer. So that's the game plan. I somehow need to get this with one base, and that base needs to be 7. Well, if the base needs to be 7, I need to change this 49 so it has a base of 7. Let's go ahead and do that. 49 is the same thing as 7 squared. So this is now 7 squared. That's 49. And this 49 is still to the power of x, so this is still to the power of x. And this is all divided by 7 to the power of 6x plus 5. Still, that denominator has not changed. And the right-hand side is still the same, 7 to the power of f of x. All right, whenever I have a power to the power, that means I'm multiplying, which means this is now 7 to the power of 2x in the numerator. In the denominator, I haven't changed, it's still 7 to the power of 6x plus 5, and that's going to be equal to 7 to the power of f of x. Nothing over here has changed yet. Okay, now I have the same base here and here, 7 and 7. Whenever I divide with the same base, what do I do with the exponents? And you should immediately be shouting out, it's division, or not division, it's subtraction. There's the right answer. Subtract. So do 2x minus the entire quantity of 6x plus 5. And do make sure you put parentheses around this because that negative is going to be distributed. So I can now rewrite this as just one simple 7. Whew. And it's going to be 2x, and I'm going to subtract the entire quantity of 6x plus 5. All right, thank you. And that is going to be equal to 7 to the power of f of x. All right, I just need to simplify. Again, this is my answer. It just needs to be simplified because if I have the same base, I must have the same exponents. That's the general rule for this lesson. So go ahead and simplify. This is going to be 7 to the power of this negative is really distributed, so it's a negative 6x, a negative 5, and I can now make this a plus. So it's going to be 2 minus 6 is negative 4, so negative 4x, and then minus 5 is equal to 7 to the power of f of x. And there's our answer. F of x must be equal to negative 4x minus 5. So we can say that down here. F of x must be equal to negative 4x minus 5, and box it. All right, that concludes Algebra 2 Notes 6-4.